So we're going to learn about metallic bonding, and we're actually going to do a lab activity today where we make an alloy. So we're going to take a copper penny and turn it into gold. So first let's talk about what metallic bonding really is. It's a bunch of metal atoms where their inner shell electrons and their nuclei are static and stuck in place, like you see here. But the outer shell electrons, or valence electrons, are allowed to move freely about. And a lot of the reason that they're such good conductors is there's usually openings within their d subshell where electrons can land, and it makes them great conductors. Now, if you apply a voltage, which you're observing right here, or just observed, you can see that the directionality of the flow can be influenced. However, when there's no electrical field being applied, then they kind of move randomly about top of the metals. And they form something called a sea of electrons, and that's how I want you to think of them. Static atoms with their inner shell stuck in place, and then their outer shell electrons able to move around. Today what we're going to do is first we're going to coat a penny in zinc. So we're going to put it in a solution of sodium hydroxide and zinc metal. And what's going to happen is the black circles represent the copper atoms. Before anything, you basically just have copper. What we're going to do is coat the outer edges of it with zinc atoms. And then that'll give it a nice shiny silvery appearance. And then what we're going to do is heat it up on a hot plate, and it's actually going to allow those zinc atoms that are sitting on the top to infuse themselves into the interstitial spaces between the copper atoms. And that's what an alloy is. It's a solution of metals, homogeneous, even in distribution, where they kind of blend together in some sort of ratio. This is very important in the development. What we're making today is brass. You could also have bronze if you were using tin. So there's all sorts of alloys that are used in the material world. One general trend is that an alloy, because you're filling the interstitial spaces, makes the metal less pliable. It's less malleable as a result, so it becomes more rigid and firm. And in a lot of industries, when you're talking about like auto mechanic parts or talking about structural integrity components of buildings, you want something that's going to be firmly held in place. Steel is kind of an example like that, where you have iron, but you have carbon, which is not a metal, infused in between the interstitial spaces, but it makes the iron much stronger and able to withstand a greater weight load. So it's really important in our world. Pause. As you can see in this video, we've turned a penny into a silver penny by coating it with zinc. Now we're going to take an additional silver penny, and we're going to put it on a hot plate, and we're going to watch it turn from silver to gold right in front of our eyes. With patience, of course. And you can see that now we've made a nice alloy. I'm going to quickly transfer this. Put in some cold water. Take it out. And you can see here that we've made both a silver and a gold penny out of the copper penny. All the way to the right, you can see a brass penny, which is a combination of zinc and copper, forming an alloy as the zinc metal basically infuses into the copper.